Hi there! Welcome to Science Made Simple by Ms. Flums. For our second 9 weeks coverage, this includes unit in energy transfer and conservation. We have discussed already the forms of energy, energy transformation, potential and kinetic, electric circuits, and now we'll be learning about heat transfer. For our standard 6P38.5, ICANN developed and use models to describe and compare the directional transfer of heat through radiation, conduction, and convection. So in this standard, these are the things that we need to do. We're gonna make and we're gonna use a model so we will be able to describe how radiation takes place, how conduction takes place, and how convection takes place. And after that, we're gonna compare each of these to each other. How heat is being transferred through radiation, conduction, and convection. For a cross-cutting concept, we have system and system models. Transfer of thermal energy. Thermal energy always flows from a region of higher temperature. Remember this. From a region of higher temperature to a region of lower temperature. Net flow of thermal energy occurs only when there is a difference in temperature. So for example, if this has a 50-degree Fahrenheit and this has 50-degree Fahrenheit also, there will be no transfer of energy because they are just equal. Because the criterion in here is there will be an energy flow if one area is higher than the other. In this case, they are equal. So that means there will be no energy transfer that will take place. But if, for example, this has 90-degree Fahrenheit and this is 50-degree Fahrenheit, then this suffices the statement in here that net flow of thermal energy occurs only when there is a difference, when the temperature is different. So in this case, 90 is a higher temperature than 50. So there will be a heat transfer that will be going on in here. Heat will flow from an area of higher concentration in A to an area of lower concentration. So that is what you mean by heat transfer. So heat transfer actually has 3 types. We have conduction. So we have conduction, convection, and radiation. Conduction is happening when energy is transferred by direct contact. So pay attention with this keyword, direct contact. Convection, energy is transferred by the mass motion of molecules. Mass motion of molecules. Whereas radiation, energy is transferred by electromagnetic radiation. In this case, there is no direct contact. Okay? No direct contact. That's for radiation. We're gonna talk more about that in detail as we discuss each of this heat transfer. Radiation. Radiation is the transfer of energy through space without particles of matter colliding or moving to transfer the energy. A very good example of this radiation is when this heat of the sun in here, is our ultimate source of heat energy. Okay? This is the ultimate source of heat energy. So heat will travel through an empty space in here because we all know that in the outer space, there's no gas. It is only when heat will reach the atmosphere that surrounds the Earth. And that's when there is now the gas in our atmosphere. So we can say now that this heat from the sun can travel through empty space in the outer space, and then it can also travel through the gas of our atmosphere until it reaches the surface of the Earth. So this is the process of heat transfer from the sun, which is the ultimate source of heat, and it travels through space, through the gas of our atmosphere, and reaches the surface of the Earth. That is what you mean by radiation. Furthermore, radiation can transfer heat through a medium or through space. But take note, there's no contact, or whereas the source of the heat, you cannot see the source of the heat really touching the receiver of the heat. Okay? So there's just like an invisible thing in between them that you don't see, but you can just feel it. So when you are standing, for example, on Earth, and you stay under the heat of the sun, you don't see anything touching you, but you just feel the heat of the sun, because the heat coming from the sun travels through empty space, through the gas, and reaches you, and you absorb that heat. Thereby, that process now is what you call radiation. That's a type of heat transfer, that there's no contact, but it travels through a medium or space. Thermal heat energy flows from an area of higher temperature to a lower temperature. In that case, the area of higher temperature here is the sun, and the area of lower temperature here is us on Earth. The same as this. So when you feel cold and you just place your hand on top of this fire here, you're not actually touching the fire, but you can feel that heat is transferred from the fire to your hands. You're not burned, but you can feel the heat, and there's no contact. You're not touching it, but heat is being transferred towards you. So from this area of higher concentration to an area of lower concentration, but there's no contact in there. So here's another example, like your car under the heat of the sun. So radiant heat energy moves from an area of higher concentration or higher temperature to an area of cooler temperature. So that is also by way of radiation. So here are some more examples. We have, you feel that your house becomes warm because of the heat of the sun, and that is happening through radiation. And I have shown this one already earlier. Conduction is another type of heat transfer. It happens when heat from a source, just like this one here, causing the atoms of solid to vibrate and gain kinetic energy. So these atoms cause neighboring atoms also to vibrate, and that kinetic energy is transferred now from one atom to another. Heat energy is conducted through the solid in this way. As the atoms of the solid gain kinetic energy, the temperature now of the solid increases. So basically, conduction is a process wherein heat is being transferred through direct contact, just like this one. So this is, you see the fire actually touching our rod in here, our metal rod. And then if you are holding that rod, you will notice that heat coming towards your hand. That is what you mean by conduction. So here are some examples also. So you see this is already in direct contact with the source, and the same with when you are cooking, and there's the heat source in here, and it's in direct contact to your container in there. When you touch that metal container, then you will feel the heat. So where does that heat coming from? From this area here with the higher temperature, and it moves towards the area of lower temperature. So conduction is usually faster in certain solids and liquids than in gases. So there are materials that are good conductors of thermal energy, and we call them thermal conductors, and they are usually metals. Materials that are poor thermal conductors, we call them thermal insulators, and those are non-metals. So just look at this. If this is a hot water in here, and you dip a metal spoon, a wooden spoon, and a spoon made of rubber, so you will notice that these are different materials in here. They are placed in the same container, but when you touch them, they have different temperature. Because this metal is a good thermal conductor, so this will warm faster than the wood in here, which is an insulator, as well as the rubber. Convection is another heat transfer. This is when heat energy moves as currents and fluids. So in convection, particles with higher energy move from one location to another, carrying their energy with them. So in this case now, if you look at this is the source of heat. So the tendency of a warm water, it will rise. But as it rises also, the temperature cools, or the upper portion here has a cooler temperature. So the tendency of that water, it will sink again because it's cooler. So cooler temperature has more density than warm temperature of air. So there will be this circular movement now. Warm air rises, cool air sinks. So heat transfer occurs when particles with higher energy move from warmer to cooler parts of the fluid. So uneven heating can result in convection, both in the air and in water. This causes currents in the atmosphere like wind and in bodies of water on Earth, which are important factors in weather and climate. We have discussed already this sea breeze and land breeze. So these are examples of convection. It's a circular movement when warm air rises and cool air sinks. Same in here. And it works also under the earth. That's why it causes the movement of our plates. So you'll learn more about this when you go to 8th grade. So to look at again this illustration, so this illustration will basically explain to us heat transfer. Here you will see that there's the sun, it's the ultimate source of heat. The transfer of heat is coming from the sun going towards the object in here. Whereas here, the hot and cold, this is, by the way, this is radiation, and this is conduction, and this is convection. So hot air rises, cool air sinks. Hot to cold. And from here, from the sun, which is the ultimate source of heat, traveling through space and through different medium until it reached the receiver here. So this is now our heat transfer.